Okay, we continue with part two, which is basically a continuation of the slides. So, SQL allows us to interact with the database. You can you can send in commands that query the database. By the way, I believe it's very clear that SQL means structured query language. So it allows you to send query to the database so you can retrieve information stored in the database. You don't have to retrieve everything in the database. You can query only what you want, and you use SQL commands for that. And you will be seeing some of those starting from the next slide. Most relational database management systems, which is RDBMS, support standard SQL. So ANSI, the S here stands for standard, standard SQL. And apart from the standard SQL, there are other types of distributions of the SQL. They include this MySQL, which is open source, T-SQL, SQLite. And SQLite is the one we're using in this course because it comes with Python. You don't need to make any installation or configuration. It's already part of your Python installation, and it's very portable, works with mobile phones, tablets, and all of that because it's very light. So SQL allows you to write statements that your database management system understands. And examples of your database management systems, DBMS, are these. So we interact with information in your database directly or using an app. You can also query information from the database management system itself. And I'll show some of these when we go into the Python section. In the role of interacting with data, SQL is a data manipulation language, DML, because you're using it to manipulate the data. These are just definitions. SQL also offers features to allow you manage the database by itself by creating and modifying tables and controlling the access to the tables. Like I said, when we talk about access control, we're talking about who is able to modify some parts of the database or all of the database and who is able to read from it. That's all access control. And SQL gives you features to manage your database. When SQL is used in that form, it acts as a data definition language, DDL. When it's used to control access, like so, it's data control language, DCL. When it's used to to create and modify tables, is the data definition. To control access, data control language. Just definitions, nothing special here. A SQL statement is composed of clauses, so it looks like English words, which can contain expressions and predicates. The clause could include a keyword specifying some action to be taken and something to be acted upon or used. The expressions and predicates set parameters within which to operate. If all of this is sounding weird, the next slide will make it very clear. So these are examples of SQL statements. So we talked about it containing keywords. Well, these are your keywords and they're English words, right? Select. You have an intuition of what this means. From. So we're selecting some data from somewhere and we're putting a condition where, last name, and everything else are predicates. So we don't care about all of the definitions. The important thing is knowing the right keywords, the right SQL commands to get the job done. So here, I want to select the first name and last name from a customer's database table, which I showed before, where the last name is equal to Jordan. So basically this will return the first names and last names of everyone in the customers table who has a last name Jordan. So the first could be Michael Jordan, it could be Janet Jordan. It's going to give you all of the customers whose last name ends, whose last name is Jordan. So that's a SQL, an example of a SQL query or a SQL command. The SQL statement will show you the first name and last name of every record in the customers table that has the last name Jordan, like I explained. Note that SQL is not case sensitive, unlike Python, right? Python is case sensitive. So because it is not case sensitive, you could write out everything here in small letters. We just choose to write the keywords in capital letters, so it's intuitive, it's easy to understand what's going on. So that's just good programming practice. Another example of a SQL statement: select. This time around we want 3 fields, right? 3 columns: first name, last name, birthday. From what table? From the customers table. And we want to order these results. When it gives it to you, order everything, sort it by birthday from the youngest to the oldest. So that's another example. So we're using this extra optional argument instead of the where, and we're also getting 3 fields instead of 2 like is shown here. And you will see Python code that does all of this when we get to the notebook demonstration section. CRUD, it's just an acronym for create, C for create, R for read, U for update, D for delete. These are the 4 basic operations that you can perform on most databases. CRUD: create, read, update, delete. Very common multiple choice question. A database can be created using the command create database. You see, everything looks intuitive. Create database, yeah, that creates a database. And then you specify the name you want for the database. That creates the database, but there is nothing in the database. So no tables in the database, no columns, no nothing. Now we need to create tables, and we use create table. So different from create database. This creates the database and gives it a name. This creates the table. A table. What's the name of the table? Table name. What's the name of the database? Database name. So you provide that. You specify these. These are not keywords. This could be anything. It could be AW, XW, whatever. Same with this. You specify the name. Then you begin to provide the fields. So this could be first name. This could be age, but you also need a second item data type. So if this is age, this will be what? Integer or float, whatever you choose. It's going to be some form of number. And if this is first name, then this will be some form of text or string, and you will see those shortly. We can insert data into a database table as shown here. So let's back up. Here you create the database. There is no table in there. Here you create a table, and here you insert data into the table. So this doesn't contain anything. It just creates an empty table with a table name and tells you the data type for each of the fields that will be stored in the table. Now you actually populate the table with data. So you use insert into for that. Insert into table name. Hopefully you already created a table. Then you provide the data you want to store in the different columns. This will be the field, and this is actually the data. So this could be numbers. So this could be 24, 32 for the ages, and this will be telling you the field name. So this will be age. This could be, or let's make it simple. First name, age, that's the field. Then here, first name, Michael, age 54. So that's basically the syntax for C in CRUD, right? 4 basic operations. All we've looked at here is all about create, because there are 3 steps. You create the database, you create a table in the database, and you insert data into the database table. Now we move on to R, read. As you can probably guess, this is retrieving information. So you use the read command to, not read command, but read means retrieving information from a database. What command do you use to read or retrieve information? Select. And you already know this because we looked at this in the previous 2 slides, right? 2 slides ago, we looked at this. So select will select whatever fields you want from whatever table you want with the condition. This is all optional, right? If you don't put this, it's going to just return first name and last name of everyone in the customer table. This condition reduces what it returns to only customers with the last name Jordan. We move on to U, update. If you want to change an existing record or table in a database, you use the update keyword. Update the table you want to update, then what fields in the table do you want to update, and what value do you want to put in there now. It used to be 24 years, now you want to change it to 54. You provide that value here, and you can use this condition, right? Optional. D, the last of the 4 basic operations, delete. As the name indicates, you use it to remove a record from a table. So you can delete from the table where whatever condition you choose. You can delete from table where condition or where last name equal Jordan. So it's going to remove all customers with a last name Jordan from your customers table if you choose. So that's the summary of the 4 basic operations, right? C for create, and you saw there were 3 steps. You created database table, you created database, that's step 1. Step 2, you created the table in the database. Step 3, you inserted data into the database table. That's all for C, for create. Then for R, to read, use select, as shown here. For U, update keyword. For delete, delete keyword. And that summarizes the 4 basic operations you perform on databases. And you see, database is very easy and very powerful, very useful. I mentioned this before, that SQLite is the relational database management system we'll be using with Python. It's already installed with Python. You don't need to make any installation. It's there already waiting for you, waiting to be used. It's based on the SQL language, but it's optimized for using small environments like mobile phones and tablets. So it's smaller features, the most useful features, so that it's very light, which is the light in SQLite. And your queries in SQLite are very much similar to standard SQL. There are 5 data types in SQLite, so it's a restricted or smaller subset of what you have in the full standard SQL, because there's way more in the standard SQL. First is null, which means if data is missing, set it to null. Integer, you know what this is. Real is your float. real numbers. Text for strings. Blob, we don't normally use this. It's for binary large objects. You can use it for images and all, but we are not going to be doing that. So there is no date type. There are so many other data types that are not available here. So if you have date, we're going to have to use text. So life is all about give and take, right? It's very light and fast. Well, it's limited in the number of data types, but we are able to do what we need to do with these limited data types. Most of the time, we're just going to be using text, integer, or real. So it omits some standard SQL features, such as right join, for each triggers, drop column, multi-column, and we're not going to be using most of those.